We're here at the Agronomic Research Center at SIU Carbondale's campus in Southern Illinois. I'm here with Dave Quartz, and we are checking out some corn roots this afternoon. Dave, can you tell me a little bit about the trialing strategy for New Leaf Symbiotics when it comes to corn products and how you've set up the trials that we were looking at here today?
Well, that's a great question, Caroline, and as you're well aware, we were just, a quarter mile away. We have one of our replicated trials that we're looking at in-furrow applications of methylotropes, or M-tropes as we like to call them, and we've got everything from just a standard seed, treated corn, and then we've added the M-tropes as an additional treatment as an in-furrow application. One of the things that's really important to understand is that in our trialing program, we try to do at least 6 replicates. It's very important when we're testing to get as much replications to try to even out and standardize the data. And then additionally, we spread those trials out over large geographical areas, not only to get different soil types, but also different weather patterns. It's been really, really wet this year to this point. And as we get into the later summer months, we're probably going to start to see some of the benefits of Terrasym technology and M-tropes specifically on corn when we start to get hot and dried, pollination in that point.
Awesome. So just a quick recap for those who may not be familiar. Can you speak to what are M-tropes and what are we trying to accomplish in terms of a corn product with that technology?
That's a great question too. So M-tropes are gram-negative bacteria that are found widely in nature. They're terrestrial bacteria that every living plant on the planet has them. They basically work through harvesting and eating the methanol that is produced as a byproduct of natural plant growth and development. That's really important in how they differ from normal rhizobia is that there's no demand, no photosynthate demand from the plant for those individual bacteria to live, grow, colonize, and continue to grow within the plant. And so each one of these bacteria that we've brought forth have certain capabilities that we like to basically help the plant do naturally by itself by, giving them more of those bacteria to be able to help them along. And so in the case of like Terrasym 408, which we'll talk about here, that's a biostimulant, and it helps through increasing root development. And increasing root development will ultimately result in increased water uptake, increased nutrient uptake, better structure standability late season, those type of things. And all of that ultimately results in higher yield.
Okay, so you mentioned water uptake. Roughly how many gallons of water does it take to grow a corn plant in a season?
It depends on the hybrid.
Okay.
What I will tell you, a good rule of thumb is somewhere between 40 and 50 gallons to raise, basically a bushel of corn per acre. So. Okay.
So you mentioned that some of these unique M-troph or methylotrophic strains have distinct capabilities. Can you tell me kind of what you're looking for in regards to those capabilities with these products or these plants?
Yeah,
in this
sure.
today?
So let's take a look, for instance. So what I may do is I may have you hold this one just so that we can, so this is just a standard elite genetics with a standard seed treatment that was already on it. That's what we're using as our quote unquote untreated check. That's what we're comparing to. So most growers would go out and plant treated seed corn. So that's what that's representing.
Right.
This one here, and I guess is the Terrasym 408 product that we just kind of soft launched this year that's going on full launch next year. And I think the first thing that you can notice when you look at this, and you can look at it sideways and you can look at it up and down, but if you go here is just the sheer diameter of the root mass that's involved. And then probably more importantly is the type of roots that are here. This one, if you dig it up and you look at it, you go, wow, there's really nice roots there. They're long, they're white, they're healthy. But when you compare it to this, the one thing you notice that it's lacking is what we call fine, superfine, and medium roots. And these are the ones that we need and that the plant needs to take up water, nutrients, and all the things that help it grow. These bigger ones tend to be more structural and help the plant support itself as we move through the year. Most people know them as brace roots. And so that's what we're looking at. And so when you compare these two plants, you can see that, there is significantly more diameter on the 408 treated, and there's significantly more fine, medium, and superfine roots that are necessary for taking up water. And so right now, with the moisture we have, this isn't really that critical. But as we get farther into the summer, most people understand that things dry up. These are going to be critical when we start to need more water to support that plant and finish out the grain. So.
Sure. Awesome. So what's this other one we've got here?
Well, that's interesting. So this is a single strain bacterial, methylotrope. And some of the things that's really nice about being able to specialize specifically in emtrophs is that we know lots about each strain. And so we've looked at doing what we call a combination. And so this one actually has 2 strains. This is one of our pipeline products. And I'll once again reference the same type of situation. We have a bigger diameter. We actually have better brace root development at this point, more superfine, fine, and medium roots that are there to take up lots of nutrients and water. And it's just another one of those products that's in the pipeline that we're evaluating. We're obviously comparing that to the untreated as well as our commercial product that we just launched. And as you see, when you look at even these two, there is some significant similarities in the amount of root. So I've got to feel very, very good and confident that the emtrophs are doing what they're supposed to do. They've colonized this root rhizosphere. They're helping the plant produce more of what's good for it, which is roots. And the ones that are important are the ones that are going to help us take up nutrients and water.
Awesome. So just to be clear, this is the
Untreated?
untreated check. This is our commercial soft launch Terrasym 408.
And this is what is a
candidate.
pipeline candidate that is yet to be named, but right now is doing very, very well in the trials that we've seen to this point. We've seen this similar type of performance throughout the U.S. I mean, our trials stretch from North Carolina to central Nebraska for corn, and we've seen very, very similar performance across the board. And at the end of the day, as most growers will tell you, it's what's the grain in the tank that pays the bills. And so we're very anxious to get to harvest and see how things come along and what the trials do and what what we get out of it and how it looks.
Sure. You mentioned that we know a lot about individual methylotrophic strains and can select those out to solve for unique problems. What are some of the corn pest and disease aspects that we're trying to mitigate with some of that methylotroph selection?
Well, and so that's a really good question. So we've talked today really about biostimulant-based products, and biostimulants are those things that help a plant do what it naturally does better. As you alluded to, there is opportunities within the methylotrophic bacteria species to be able to help to reduce or mitigate pests such as corn rootworm, fusarium, like corn, some of the leaf blights, gray leaf spot. There is some opportunities to help mitigate like pythium that we see in small grains and soybeans. So those are very specialized. They require a little bit different labeling and a little bit different way to come to market, but we're actively pursuing all of those and look forward to seeing those out in the market in the next couple of years.
And how does New Leaf Symbiotics select or nominate those methylotroph strains?
That's not the easiest question. We have a very robust bioinformatics database known as the Prescriptive Knowledge, PBK, the Prescriptive Biologic Knowledge Base, and we take phenotypic data, genotypic data, trial data, all the things that come in, how we grow them, all these things come together into this bioinformatics database. And so, for instance, if we wanted to look at how do we mitigate like white mold, for instance, we might say there's certain places within the disease cycle that are there's certain biochemical functions that are happening within the plant. And we might have emtrophs that are capable of producing certain metabolites that would interfere with that disease progression. We'll focus, and the PBK will help us select based on what those biochemical functions that are happening in the plant or in the disease that we need to help stop. So. Gotcha.
One last question kind of about root establishment. It's been a really weird year for most of the Midwest in terms of planting late, wet. What does a root system like this, what advantage will that have for a farmer as we get later into the season? And you alluded to that a little bit earlier.
I think at the end of the day, the key function is that we know this water is going to shut off. It always does, and especially we're here in southern Illinois, and it gets hot and dry really quick. The better established root system, the more fibrous and fine and superfine roots that you have, give the plant more advantage for water uptake, nutrient uptake, gas exchange with, we need air as well, and then ultimately helps it stand late season. If we start to have serious, deteriorating weather this fall, we're going to want to make sure that the plant has good stability, and those brace roots and all those other roots that are part of that root mass will help it stay standing long enough to be harvested.
Awesome. So key takeaway, the commercial product that we've got out this year looks pretty good.
I'm pretty impressed with the way it looks good.
And the pipeline looks good too.
It does.
So
very good. Thanks, Caroline.
Awesome.